Imagine for a second that you live in Edmond, Oklahoma. It's mid-July, the sun is just beating down, the humidity is completely oppressive.
Oh, yeah, the absolute worst time for something to go wrong.
Exactly. And your air conditioner, which has been making this weird rattling noise for a week, finally just gives up the ghost. So you are sitting there sweating in your own living room.
Right, a highly stressful situation that pretty much all homeowners face eventually.
Hmm.
And usually it's when you are least prepared to make a major financial decision.
Yeah, and here is where the anxiety really kicks in, right? You call a local HVAC company, a salesman sits at your kitchen table, and he gives you 3 bids for a brand new system.
3 options. Standard industry practice.
Right. So bid number 1 is for a standard single-stage air conditioner, and the price is $8,500.
Which hurts, but you sort of expected a big number.
Yeah, exactly. You wince, but you accept it. Then he slides over bid number 2, which is a 2-stage unit for $10,500.
A pretty significant jump right there.
Oh, but wait. Finally, he presents the premium option. This is a top-of-the-line variable speed system. The price tag on that one is a staggering $14,500.
I mean, that is a massive $6,000 spread from the bottom to the top.
It's a huge chunk of change. And a $5,000 jump just to get from that middle option to the premium tier.
And of course, the salesman is going to tell you that the more expensive one is obviously better, right? That it's highly efficient, the future of comfort, all that.
Yes. And I've always wondered, are these premium tiers actually worth it? Or is it just, a really clever way to separate homeowners from their money?
That's the perfect question.
So our mission for today's deep dive is to cut right through that heavy marketing push. We want to look at the cold, hard math of this $5,000 decision. We need to figure out when that massive upgrade is actually a legitimate investment for you and when you're just paying a premium to feel like you bought the best.
I think that distinction is incredibly important. The salesman at your kitchen table isn't necessarily lying when he says that variable speed unit is an incredible piece of technology.
Right.
But he is jumping to a really massive conclusion if he assumes it automatically belongs at your specific house. The technology only works if the application is actually correct.
Yeah, that makes total sense.
Yeah.
And to guide us through this today, we have some just phenomenal source material. We are looking at field data and notes directly from Dave Hartzell of Hartzell's Heat and Air.
A fantastic source.
Yeah, Dave is based out of Kingfisher, Oklahoma, and he has 45 years of experience as an HVAC master. The notes mention he's NATE certified too.
Right, which is the North American Technician Excellence Certification. That's basically the gold standard for verifying that a technician actually understands the complex physics of heating and cooling.
Instead of just knowing how to swap out broken parts.
Exactly. He's also a top-tier Trane and Mitsubishi dealer. So we're pairing his decades of on-the-ground reality checks with some really solid residential AC efficiency analyses from Energy Star and the AC.
It's just a great data set to work with. I mean, someone with 4 decades of field experience has seen literally every trend in heating and air come and go.
Yeah, they know the difference between a passing marketing fad and what actually keeps a house comfortable when it's 100 degrees outside.
So before we can even touch the math on whether that $5,000 premium is worth it, we kind of have to understand what changes inside that actual metal box sitting outside your house.
We really do need to define the hardware first.
Yeah, because we're throwing around terms like single stage and variable speed. Let's demystify that. What are you actually buying when you move up these tiers?
So at the most fundamental level, we are talking about 2 main components. There's the compressor, which is the engine outside pumping the chemical refrigerant. And then there's the blower motor inside that actually pushes the air through your ductwork. So let's look at that basic model first, the $8,500 bid.
The single stage.
Right. A single-stage unit operates in a completely binary way. It is either completely off or it is running at 100% maximum capacity. There's no in-between.
Oh, I see. So when your thermostat detects that the living room is, say, a degree too warm, it just kicks that system on full blast until the target temperature is reached, and then it shuts completely down.
That is the traditional cycle. Yep. Now, the next step up, the 2-stage unit, introduces a little bit more nuance.
Okay, how so?
It basically has 2 gears. It features a low setting, which typically runs at about 65% of its total capacity, and then has a high setting for when the summer heat is just overwhelming and it really needs to run at 100%.
So it's not just all or nothing. But then we get to the $14,500 mammoth, right? The variable speed, or what the industry apparently calls a modulating unit.
Modulating, yeah.
Since the leap in price is so huge, I'm guessing the leap in mechanics must be pretty significant.
Oh, the technological leap is massive.
Hmm.
A variable speed unit doesn't just toggle between two gears. It can operate anywhere from about 25% of its capacity all the way up to 100%.
Wow, really?
Yeah, shifting in incredibly fine increments. It constantly adjusts itself based on the exact temperature and humidity of the home at that moment.
That's wild.
And on the really high-end units, the compressor outside and the blower fan inside are actually communicating and modulating together. They do this to perfectly match the real-time cooling demand of your house.
Okay, I understand what it's doing, but how is it actually achieving that? Because, I mean, a standard motor just gets hit with electrical current and spins at a fixed speed, right?
Yeah.
How does a machine suddenly learn to run at exactly 37% capacity?
It all comes down to inverter technology.
Yeah.
So a standard single-stage compressor receives a fixed alternating electrical current from your house. It just takes that raw power and runs at a single unchanging speed.
Right.
But a variable speed unit uses a complex electronic inverter to take that incoming power, convert it, and alter the electrical frequency being sent to the motor.
Oh, I get it. So by rapidly changing that frequency, the system can precisely dial the motor's rotational speed up or down.
Exactly.
You know, I love a good analogy, and the way I'm picturing this shift in technology is like driving a car.
Okay, let's hear it.
So a single stage air conditioner is like a car that only has two speeds, 0 miles per hour or 100 miles per hour.
That sounds dangerous.
Right. If you want to drive through a quiet residential neighborhood, you literally have to floor the gas pedal to 100, slam on the brakes to 0, floor it to 100 again, and slam on the brakes.
A terrible and highly inefficient way to drive a vehicle. But honestly, that is exactly how millions of homes are cooled today.
But the variable speed unit with that inverter technology is like having a normal gas pedal. You can just cruise smoothly at 25 miles per hour, adjusting your speed exactly to the flow of traffic.
Yeah, that visual captures the mechanics perfectly. You rarely ever need to floor it to 100 unless you're merging onto a highway on the hottest day of the year.
Exactly.
Moving air slower and more constantly changes the entire dynamic of the house's airflow. When a system isn't just blasting air at maximum velocity every single time it turns on, the physics of your home's thermal environment fundamentally shift.
Okay, so here is where I think we need to examine the sales pitch. Now that we understand that the variable speed system acts like a smooth, highly sensitive gas pedal, why does HVAC marketing push this so aggressively?
They push the comfort aspect.
Right, like when they hand you that $14,000 bid, what are they actually selling you on to justify the cost?
The industry is selling you on an elevated level of comfort, and it revolves around three very real benefits. First is quieter operation. Because the system is often cruising at that 25 or 30% capacity, the decibel level of both the outdoor compressor and the indoor blower is drastically reduced.
Which I imagine is a massive selling point for overnight comfort when you are trying to sleep. Nobody likes waking up at 2 a.m. because their AC kicked on sounding like a jet engine right outside their bedroom window.
Exactly. It's a huge quality of life improvement.
I can definitely see the appeal there. What's the second piece of the pitch?
The second is more even room-to-room temperatures. With a single-stage unit, blasting cold air and then shutting off creates really noticeable temperature swings.
Oh, right. Like certain rooms might get freezing cold while rooms further from the unit stay warm?
Yes, and then the temperature slowly rises everywhere until the next blast. A variable system pushes a gentle, continuous flow of conditioned air, which thoroughly mixes the air throughout the house. That eliminates those hard hot and cold cycles.
Okay, so quieter operation and even temperatures. But earlier, the data mentioned humidity control being a major factor. How does the gas pedal analogy apply to pulling moisture out of the air?
Well, the humidity control is arguably the most critical piece of the comfort puzzle. Because the variable system runs for much longer periods at a lower capacity, it dehumidifies the air much more effectively than a system that just turns on and off rapidly.
Now, I have to push back here a little bit.
Go for it.
I hear quiet operation and even temperatures, and to me it sounds like a very nice luxury. But does a house actually need this? Or is this just the HVAC equivalent of, say, buying heated leather car seats?
I see what you mean.
Sure, it's a great feature, but is it a $5,000 necessity?
To understand why it transcends just being a luxury feature, we have to look at the physics of how an air conditioner actually removes humidity.
Okay, let's get into it.
An AC doesn't simply cool the air, it conditions the air by pulling moisture out. Warm, humid indoor air is pulled through your return vents and passes over the freezing cold evaporator coil inside your ductwork.
Right.
When that warm air hits the cold metal, the moisture in the air condenses into water droplets, drips down into a pan, and drains outside.
Oh, that's just like a cold glass of lemonade sweating on a hot summer day. The moisture in the warm air condenses on the cold surface of the glass.
That is the exact same principle.
Yeah.
And that condensation process is the key to a comfortable home. But here is the critical factor. The process takes time. The system has to run long enough for the coil to get sufficiently cold, for the air to pass over it, and for the condensation to physically occur and drip away.
Oh, let me guess. If you have a single-stage unit blasting at 100 miles per hour, it might satisfy the thermostat and cool the room down in like 10 minutes.
Yep.
And then it shuts off before it has had a chance to extract any meaningful amount of humidity.
Exactly. The room gets cold quickly, but all that airborne moisture is just left behind.
So the house feels cold, but it feels clammy, like cold and damp.
Yes. By pushing a little cold air constantly over a much longer period, a variable speed unit gives that evaporator coil hours of continuous time to wring the moisture out of the house.
That makes a ton of sense.
In a humid climate, or even in a tightly sealed modern home where everyday moisture from cooking and showering just gets trapped inside, that isn't just heated leather seats. That is the fundamental difference between your house feeling like a comfortable sanctuary or a damp basement.
Wow, okay. I completely see the comfort angle now. It is a fundamentally different physical experience inside the house.
It really is.
But here is the $1 million, I guess the $5,000 question. If I am the homeowner at that kitchen table in Edmond, I'm probably looking at the salesman and thinking, well, you said this variable unit is wildly efficient.
Right. They always push the efficiency.
Yeah, that it uses way less electricity.
Yeah.
So sure, I'm paying $5,000 more up front, but the energy savings will pay for that upgrade over time, right?
And this brings us to the cold, hard math of the situation. This is where Dave Hartzell's field experience really cuts through all that marketing noise. Let's look at the actual documented energy savings of this highly efficient variable system in the real world.
Okay, let's do the math. What are the actual savings here?
According to the field data in central Oklahoma, replacing a single-stage unit with a high-end variable speed train system typically saves the homeowner between $200 and $400 a year in electricity.
$200 to $400 a year. Let's average that to an even $300 in annual savings just to make it simple.
Okay, now take that $5,000 premium you paid up front and divide it by your $300 in annual energy savings to find your break-even point.
Let me do that math real quick. 5,000 divided by 300, that's 16.6. So basically almost 17 years. A 16 to 17 years simple payback period just to recoup the initial upgrade cost.
And the crucial catch that often gets glossed over in the sales pitch is that modern residential air conditioning systems are generally rated for a 15-year useful lifespan.
Wait, are you serious?
I am.
Let me get this straight. The machine is rated by the manufacturer to die at year 15. But it takes 16 to 17 years to pay itself off in energy savings. It literally expires before it breaks even.
The math simply does not pencil out if you are only looking at your electric bill. Energy savings alone will never mathematically pay back the variable speed upgrade.
That is a massive aha moment. I mean, the marketing leans so heavily on words like efficiency and savings, making you feel like you are making this incredibly smart, responsible financial choice.
But if the machine dies before the payback date, it's not a financial investment at all.
Right. So the comfort and the humidity benefits must be the primary reason you buy a variable speed system.
Absolutely. If you do not actively value the quietness, or you do not have noticeable humidity issues, or you just don't care about ultra-precise temperature control, buying the variable speed unit is objectively a bad use of your money.
Okay, so if the energy math doesn't work out, who should actually be buying these $14,000 systems?
Dave Hartzell's notes break this down perfectly into finding the right fit. The variable speed technology works brilliantly in specific scenarios.
Like what?
For instance, central Oklahoma houses, where the summer heat is so intense that the system naturally runs 8 or more hours a day during the cooling season.
Oh, because it's running so heavily. That low, slow, modulating gear gets utilized constantly, right? Maximizing the comfort benefits.
Exactly. It's also incredibly useful for two-story houses where the upstairs always feels like a sauna while the downstairs is freezing.
Yeah, that constant, gentle mixing of air would slowly balance the two floors out without just blasting the downstairs occupants with freezing air.
The data bears that out completely. It's also the right fit for homes with specific, nagging humidity complaints, or for buyers who simply value pristine overnight bedroom comfort over the price tag.
Yeah.
If you have the budget and want the absolute best environmental feel in your home, it delivers.
So if that is the right fit, who is getting upsold when they really shouldn't be? Like if I have a smaller single-story house where a standard unit has always easily maintained the temperature, is this a complete waste?
It is entirely unnecessary for that scenario. It's also a waste for users who only run their AC during the absolute worst summer days and leave the windows open otherwise.
Because you aren't running the equipment enough hours to reap any of the modulating benefits.
Exactly. And if your house already has perfectly balanced ductwork and zero humidity issues, you are paying a massive premium for solutions to problems you don't even have.
Okay, let's talk about the homeowner on a budget. If I don't have an extra $5,000 lying around to treat myself to premium comfort, does that mean I just buy the standard single stage and accept a clammy, less comfortable house?
Not at all. And this is the secret most aggressive salesman won't tell you. If you are on a tight budget, taking that $5,000 difference and putting it into the envelope of your house is a much higher return upgrade than moving from a single stage to a variable speed AC.
When you say the envelope, you mean things like blowing new insulation into the attic or maybe paying to have leaky ductwork sealed up so cold air isn't blowing into the walls?
You hit the nail on the head. Upgrading the insulation and sealing the ductwork fixes the root problem of the house.
Right. It actively stops the summer heat from getting in, and it stops the cold air you just paid to condition from leaking into the attic.
A highly expensive variable speed AC is often just treating the symptoms of a poorly insulated house. Fix the house's envelope first. It provides a better return on investment every single time.
Fixing the root cause instead of treating the symptom. I feel like we just saved someone listening $5,000.
I hope so.
But we aren't done yet because the source material points out one final devastating trap to avoid. Even if you have the perfect house for a variable speed unit and you have the budget ready to go, there is a technical step that, if skipped by your installer, ruins the entire investment.
This is the absolute deal breaker. It's a sizing calculation called a manual J.
A manual J. That sounds highly technical. What actually goes into that?
A manual J is a highly specific mathematical heat load calculation.
Yeah.
A proper HVAC contractor doesn't just look at the square footage of your house.
Mm-hmm.
They measure your windows, check which direction those windows face relative to the sun, inspect the R value of your insulation, and calculate exactly how many BTUs of cooling your specific house requires.
BTUs being British thermal units, the standard measure of heat energy. So instead of a contractor just eyeballing it and saying, well, you have a 3-ton unit sitting out there now, let's just slap a new 3-ton unit back in, they're actually doing the physics to see what the house demands today.
Relying on rule of thumb sizing, or just swapping like for like, is incredibly dangerous. Sizing matters more than the tier of the equipment on almost every job.
Wait, really?
Yes. If a contractor gets lazy and installs an oversized variable speed system, it completely loses its modulating advantage.
Because the machine is physically so large that even its lowest 25% gear is too powerful for the house?
Exactly the problem. Its lowest setting might blast the house cold in 10 minutes, meaning it shuts off rapidly like a basic single-stage unit, entirely defeating the purpose of paying $14,000 for a system designed to run continuously.
Oh man, that's rough.
And it gets even worse if they oversize a single-stage system.
I can see where the physics break down here. An oversized single-stage system would be like trying to water a delicate little indoor houseplant with a high-pressure fire hose.
That's a great way to put it.
You pull the trigger, it blasts the houseplant, dirt goes everywhere, and you shut the hose off immediately. The plant got wet, sure, but the water ran off so fast the roots didn't actually absorb anything. In a house, it blasts you with cold air and leaves the air cold but feeling like a damp swamp.
We call it short cycling, and it completely ruins a home's ability to control humidity. Think about how a thermostat works. It is usually located in a central hallway.
Okay.
If an oversized unit blasts a massive volume of freezing air, the hallway drops to 72 degrees in 8 minutes. The thermostat clicks the system off,
But the bedrooms at the end of the house haven't had time to cool down yet.
and the evaporator coil hasn't had time to pull any moisture out of the air. Dave Hartzell has a core philosophy here that is vital for every homeowner to hear.
Let's hear it.
The tier of the unit, whether you spend $8,000 or $14,000, does not matter if the sizing is wrong. An $8,500 single-stage unit, sized perfectly with a manual J-load calculation, will keep a house infinitely more comfortable than a $14,000 variable speed unit that is 2 sizes too big.
Let's bring this all together. The variable speed upgrade is completely real. The comfort benefits, the quietness, the humidity controlmentary. None of that is snake oil. The inverter technology fundamentally changes how a house feels.
Absolutely, it's great tech.
But it is deeply overprescribed by an industry that benefits from selling more expensive boxes, and the math does not support buying it purely for energy savings.
The right question when you are looking at those 3 bids is never which unit is better. The right question is which unit fits this specific house's thermal envelope, my specific budget, and my actual use case.
And the ultimate protection against making a $14,000 mistake isn't picking the right box. It's picking a contractor who will actually sit down and do the manual J math to prove what your house needs.
Couldn't have said it better.
Which is exactly why the field data from Dave Hartzell is so valuable here. If you're in central Oklahoma and you actually want to see what this math looks like applied to your own house, Dave's team does free estimates. You can find them at hartzellsheetair.com or call 405-375-4822. It's refreshing to see data from someone who prioritizes the math over the upsell.
It really is rare to find that level of transparency. And as we wrap up, I want to leave you with a final thought to mull over regarding the lifespan of these units.
Okay, what is it?
We established that a variable speed system doesn't pay for itself in energy savings over its 15-year life. But consider the actual components. Variable speed units require highly complex, proprietary modulating compressors and specialized computerized inverter boards.
Right.
Standard single-stage units use basic, universally available on-off contactors.
I feel a catch coming with those proprietary computer boards.
Oh, there is. If a major component breaks in year 10, when the warranty is getting thin or has expired, the repair bill on a basic single-stage system might be entirely manageable. But the replacement cost on a proprietary computerized modulating compressor or inverter board could be astronomical.
Yikes.
Does that massive potential repair bill make the long-term math on the premium system even worse? Are we trading upfront luxury and comfort for future repair nightmares? Something to think about the next time a salesman looks you in the eye and tells you that more expensive is always better.
Trading upfront comfort for a future nightmare. Think about that the next time you're sitting at your kitchen table, sweating in July, staring at a $6,000 price difference. Sometimes the boring basic option isn't just cheaper today. It might be the only one that actually lets you sleep soundly a decade from now.